Now that we have analyzed all of the 5 examples, let's take a look at a summary of what we found. So on slide 49 you have the data sets MWI and ORML, and on the next slide 50 you have the remaining 3 examples. And we're going to take a look at the 3 model types: regular RICLPM, the reciprocal only model, and the reciprocal model. And we'll be interested in 2 types of effects: cross-lagged effects and reciprocal effects, in which I also include lag zero contemporaneous effects in one direction. A first question we may ask is which cross-lagged effects, as determined by RICLPM, remain after also allowing for lag zero effects. So here in the regular RICLPM we find a cross-lagged effect from depression at a previous time point to self-esteem at a later time point. That effect survives in the reciprocal analysis, and the reciprocal analysis adds another effect, a lag zero effect from self-esteem to depression. So we learn something more from the reciprocal model, but it does not contradict the regular RICLPM finding of a cross-lagged effect. For the ORML data, the RICLPM gives cross-lagged effects in both directions. The reciprocal model supports only one of those effects, from depression to disability, whereas it puts the effect in the opposite direction, disability to depression, as a lag zero effect. So here we have only partial support for the RICLPM finding of cross-lagged effects, significant cross-lagged effects in both directions. On slide 50 then, we have the BLS data, which that data set is a little bit different. Regular RICLPM finds no cross-lagged effects that are significant. The reciprocal model finds no such effects either, but it does find a lag zero effect from depression to self-esteem. So here there's no contradiction between the models. For GPA, RICLPM finds a cross-lagged effect from GPA to academic self-concept. However, the reciprocal model moves that effect to a lag zero effect and has no significant cross-lagged effects. So here the cross-lagged effect finding of RICLPM is not supported by the reciprocal model. Now for the endless Y, the RICLPM model finds cross-lagged effects in both directions. The reciprocal only model moves those cross-lagged effects, those lag 1 effects, to lag 0 effects. And the reciprocal model sort of splits the difference, keeping a cross-lagged effect in one direction as a lag 1 effect, but moves the other one to a lag 0 effect. So in this case, the cross-lag finding of RICLPM is only partially supported, namely for the self-esteem to depression. Now, we also note that none of these 5 examples has an empty column, empty reciprocal or lag 0 effect. There's something there in all examples. And we also note that none of these examples has a reciprocal effect, except for the endless Y data for the reciprocal model, for the reciprocal only model. In the reciprocal model type, we only see lag 0 effects in one direction so far in these data. But I'm sure we'll see other applications in the future where we'll have true reciprocal effects also in the reciprocal model. I have done Monte Carlo simulations adding to those I showed you earlier, where I have situations of moderate standardized effects in both directions being recovered quite well in simulations. Now, looking at slides 49 and 50, we can go back to the early questions in the talk and ask, do we see more lag 0 effects or reciprocal effects in data that have longer time intervals. So you may want to look through the examples from that point of view, but I don't really see that kind of connection. Maybe there are too few examples, or maybe there are other forces that are stronger than the time interval to cause either lag 1 or lag 0 effects. Turning to slide 51, we once again look at Monte Carlo simulations, but in this case the H0 model is incorrect, by which I mean that we generate according to one model but analyze according to another one. And that corresponds to the two columns generate and analyze. In M+ language, one would call this the model population part, and this is the model part. So inspired by the MWI data, using S values, parameter values from that, I generated data according to the RI-CLPM model, which, if you remember, had a lagged effect from depression to self-esteem. And then I analyzed by the reciprocal model, and in this case found no significant effects. And if you remember, the real data analysis of MWI using the reciprocal model found both the lagged effect and the lag 0 effect as well in the opposite direction. So here we find something different than in the real data analysis. Now the data sets that are generated versus the real data set, they're quite different, of course, because I did not generate non-normality in the variables. I did not generate attrition, missing data by dropout. But nevertheless, it is of some interest to note that these two come out differently. Now, if you generate by the reciprocal model, we had effects of both the cross-lagged and the lag 0 type. If you generate by that, but analyze by RI-CLPM, so go in the opposite direction, we do find the same effect that we found in the real data. So here we have some agreement. Now you can play around with that in your thoughts and think, does that support that the fact that the reciprocal model is the one that generated the real data? Well, that's a big leap, but it's interesting to find this similarity here. Note also this chi-square 5% issue. You have, that's the trying to find the power with which we can reject the model, this incorrect model. And among the 500 replications that I do, a proportion of 0.134 were rejected, had chi-square values greater than the 5% critical value. That's not a very high value. That's a very low power to reject the fact that this is the wrong model. The reciprocal model is wrong relative to the data generation. You have a little bit higher power, but still very low. You want power to be closer to 0.8. So that's an interesting feature, that we don't have much power to distinguish between the models. And we saw that we saw similar aspects of this in the real data analysis. For the BLS data, I only do this in one direction, generate by the reciprocal model with the cross-lagged effect, and analyze by the RI-CLPM, finding nothing for RI-CLPM, and that's the same as in the real data analysis. And the power is still very low. Going then to NLS-Y, the regular RI-CLPM finds cross-lagged effects in both directions, and that's what we generate by. And then when analyzed by the reciprocal only model, we find nothing. So that's different than the real data, where we found these two effects to be lag 0 for the reciprocal only model. Again, power is low, which is interesting because we have 8,000 observations here for NLS-Y. Now, generating by the reciprocal only model, we have the cross-lagged effect and the lag 0 effect. And analyzing by RI-CLPM, we find a cross-lagged effect, a small effect in one direction. And if you remember, there were cross-lagged effects in both directions, so that's not exactly the same as the real data analysis, but it is somewhat similar. Now, of course, it would be interesting to generate data according to a model that is neither RICLPM nor nor reciprocal. And we could do that by, for instance, as Ellen Hammacher suggested, could add a residual covariance to a model that has both reciprocals or lag 0 effects and cross-lagged lag 1 effects. Now, one could ask them which model, RICLPM or one of the reciprocal models, gets the worst bias. They're both wrong. The tricky thing with this is that it's hard to choose parameter values that are realistic because that model is not identified. So we can never get ideas from real data what are reasonable values for the parameters. And the results would depend quite a lot on the values chosen, not only for the residual covariances but also for the cross-lagged and lag 0 effects. But it is an interesting and good question, I think, because studying the effects of unobserved confounders, as this could be portrayed as, is also in line with efforts that we see in the causal inference literature under the rubric of sensitivity analysis, like for a mediation models where you have effects that you cannot identify. And there's been work on sensitivity analysis by Imai, and we cover some of them in our book, Regression and Mediation Analysis Using M+. So that's an area that could welcome some more research. On slide 52 and also on slide 53, we come to the conclusions. And from our real data analysis, we conclude that the three model types either fit equally well or about the same. All the models have log likelihood values that are not far apart. Differences are largely due to differing number of restrictions of time invariance or fixed effects. So we conclude that in this case, statistics cannot give a strong indication of which model is best. And that was also indicated by our simulations using the incorrect H0 model. We have very low power to reject the wrong model. So what is the answer to the question in the title? Can cross-lag panel modeling be relied on to establish cross-lagged effects? And it looks like the answer is no. It is hard to claim that a cross-lagged effect has been found if it is, or if it might just as well be a contemporaneous effect. So we take a look, for instance, at the GPA and endless Y analyses. So GPA, regular RICLPM, says that we have a cross-lagged effect, but reciprocal analysis says that that is a lag 0 contemporaneous effect. Endless Y, RICLPM, says that we have two types of cross-lagged effects in both directions. The reciprocal only model classifies them instead as lag 0 effects, and the reciprocal model takes one as a lagged effect and the other as a lag 0 effect. So both of these cross-lagged effects are not supported by the alternative analyses that fit the data rather, just as well. So turning to slide 53 then finally, with similarly fitting models, it is tempting to want to choose the regular RICLPM model because cross-lagged effects may offer a more interesting quote-unquote causal interpretation given the time lag between cause and effect. But as my colleague Tiomir Asparuhov says, this may be wishful thinking. because the RICLPM does assume zero lag zero effects. And you don't really want to overemphasize the lag 1 cross-lag effects at the expense of these lag zero effects that we found with the alternative models. So my recommendation here is, why don't we report results of all three model types? The reciprocal and the reciprocal only models, they are useful complements to RICLPM because they enrich the understanding of the data. The reciprocal model may actually facilitate the search for a parsimonious model by its natural time invariance restrictions. For instance, holding reciprocal or lag zero effects time invariant may be much more reasonable than holding residual covariance time invariant, as you might in the RICLPM, because of the likely time varying residual variances. In any case, the regular RICLPM typically has worse BIC in the 5 examples that we look at. In fact, I don't think it's better in any of the examples. Again, reminding ourselves that to choose between the 3 models, we cannot use chi-square difference testing because they're not nested, so we have to go by BIC. Now, one can wonder then, is the situation going to be different with the intensive longitudinal data where we have much longer time series? So the interesting thing there would be, depending on the subject matter and type of measurements, intensive longitudinal data with more frequent measurements may have less of a need to include contemporaneous effects. And that's good then if one notice or remembers that DSEM analysis with reciprocal effects is not even identifiable. So with that, I end Webtalk 5 and thank you for listening.